We have a 2-bit memory cell. Right now you can see that one of the bits is on while the other is off. And we can change that. Maybe we turn on the second one and then we click the enable or the synchronize button, or we could turn them both off and synchronize. Since we have to do them individually, what I want to try and make right now is a very basic 1-bit memory controller. So this is what we're going to be trying to adapt it to. Now instead it's a manual writer where we can input the address that we want and then the data. So in this case, if we set the data to 1 and we have our left bit selected, we can write into that. And similarly, if we move our address to the right, then we can write the value 1 into that right bit. So this is a stepping stone to where we can have many more addresses and then input the address while still using one data input to sort of make the beginnings of a memory controller. So let's get started. I guess I'm gonna have to remove this guy. Okay, so the enable signals are gonna have to be different here. In this case, this is an enable and this one's also the enable. These are the 2 clock inputs for this for the top bit and the bottom bit. So I'm going to remove this since they're going to be different signals. Right now they're kind of synchronized. That's why they work together, treating it as one 2-bit unit. But now I'm going to treat them as individual addresses. So the enables will be different. And the data input, of course, also will be different. In this case, this used to be our enable. So I'm going to remove this button here. Power from it can also be removed. So we still have our power going to our chip, the main chip that has the 2 bits on it, 2 D flip-flops. We have our overrides and our pull-down resistors here still. I'm not going to change that. We have our outputs, of course, right here. We have our data input. So the green are the data inputs and the clocks are the ones next to it that are empty. So what we need to do now is get some sort of decoder going where we can enter an address and also have 2 separate clock inputs. So the address will drive the clock input and both of the flip-flops or the bits will be connected to the data. So we need a data input still. In this case, I'll probably just use a slider switch. We need 3 inputs really. We need a data input for the value. We need the address that's going to go in. And we also need sort of like a go button to execute, like an execute button. So what I'm thinking is this can be our execute button. So I'll just wire it up with some power. And then we need our input data. So I guess I'll use a slider switch. So this will be our data input. And then we can also put an address input here. So I'll get another slider switch. So we have maybe data, address, and execute. I'll probably flip these around to make it a little bit more natural, like what address, what data, and then execute. So I'm just gonna slide this down. So we have our address, our data, and execute. So the address right now, it's only 1 bit, right? It's either like a 1 and a 0 or a 0 and 1. And then we'll choose whether it's a 0 or a 1. If it's a 1, then we need to connect these to both inputs. So it's going to go to both these green cables, the data output. And then the address selector is going to go to the clocks from those chips as well. So we'll probably just send them down to make it easy. And then that should be it. Since it's 1 bit, an actual hard switch can do it. So there's actually no decoding necessary, but I think this is a good first step. And then we can move to like a 2-bit addresser with an actual decoder. So I'll get this working just to make sure that the logic is relatively accurate. So I'm going to move down the clock inputs for this chip. All right, there's 1 clock input. I'm going to remove this yellow cable since he's no longer being used. That was used originally to set this green. It was jumped over here going down. So now I'll add the other clock input. The green are the data inputs for each bit, and then the brown are the clock or synchronize or enable buttons for each bit. And now all we have to do is run our data output to both of these lines, both green lines, and then put the address to both clocks. And I think that's pretty much it. So it's very basic since it's a 1-bit system. And then our synchronize will, I guess our synchronize button, it will be what actually powers the addresser, powers a clock. So we'll get there after. For now, we just need to connect our data line. So we have our green here, and we need to connect the data. This yellow extends the green. So maybe what I could do is use a different extension. Let me move this clock down by 1. I guess I'll make this data and this address because this guy is going to power the addresser to give it a pulse. So in this case, this is the data, and he needs to connect to the green lines. So let's get that going. All right, so data is connected to one of them through this blue into the green into the pin. And now we need to extend this green over here and have it connect. So I'll jump the middle section. And now we need to connect our green over to this jumper. Yeah, I hate to have the same color for now data and clock, but it's the one that reaches. So I'll just go with it for now. And now, so our data is now connected to both data inputs, which is accurate. I guess we need to pull this down so that when it's off, there's no floating inputs. So I'll put a 10K in there. All right, so that's pull down with the pull down resistor. We do need to power it as well. So I use this 1K just to go into this middle pin to provide power. All right, so we have power going into the button. When the button is on, then power will come out and go into the data pins, both of them in parallel. And when the data is off, then the data will see a 0 because it's pulled down by this resistor. So it's either a 0, it's grounded through the resistor, or there's power coming through from positive. So now what we need to do is get our addresser connected to both address lines, but instead of being in parallel to only one side of the switch on this one, and there's a hard off that's not connected to anything, this switch is always going to be connected to one of these two, and that's just because we're dealing with 1 bits. Hopefully if this works, we can move to a 2-bit decoder where we actually put in the address and then it will decode it through logic. But right now we'll just have a simple switch to get this working, sort of like a modular input system for 1-bit data and only two positions. So it's 1-bit data, but it's also a 1-bit addresser. To be honest, this is a bit simpler than I was thinking to start with, but I think it probably makes sense to start this way and just make sure everything works out and then build from here. So we have power going into our addresser, and now we need each side to basically go into the 2 clocks. I don't know if I need to pull them down, although I guess they're already pulled down over here, so maybe I didn't even need that for the data. The data is pulled down already. Forgot about that. So I don't need to pull this down, which will make it a bit cleaner. Now pulling this down will save us 2 resistors here, which maybe makes sense. Instead of having 2 resistors, 1 on each, we could have 1 pull down here from the source. But I'll just keep it like this for now. And then for the addresser, I don't know if we need to pull it down because I guess we already have a pull down. No, we don't have a pull down here. All right, let's see what happens. So let's connect our address to both lines. So this is which color now? Green, no, brown. So I'll put this right side to this brown guy. So I'll put the right guy to this bottom bit clock and the left position to the top bit clock. So the left side here of the addresser is connected to the clock of the top bit, and the right side will connect to the clock of this bit. So that should be a very short connection right here. So our address is connected to both of the clock inputs. You can choose which one we're talking to. And now we need to provide power to the addresser. So let's give this a shot and see. Right now, of course, our execute button is not really doing anything, but I guess we could test it and see what happens. Okay, so right now, power's on. The data is set to 0, and the address is selecting the top bit. So if I turn the data on for this, then we can see it's not really working. And that's because these are edge triggered and I'm just providing a constant value. Now, I don't know why they're both being set at the same time, but we'll get to that. So what I need to do right now is make sure that my addresser is only powered when I click execute. So it sends a short pulse to the inputs. At least that's what I'm thinking. So I'm gonna plug out the power of my addresser, and then just have the button enable that addresser. And I guess here I'll use the pull down resistor. So I guess instead of having it powered, we actually should pull it down itself. And then we can maybe squeeze in the input of our button into that same spot, or we can do it at the top here maybe. So the button is connected to the addresser, and now let's see if there's any difference in the performance. So we want to set, let's say, the top bit, although I think this was bit 2. I think I have my wires messed up. So I'm going to swap these around. I'm going to make the top bit the left bit. So I had a couple issues there. I'm going to consider pulling these down directly. All right, so let's see if this works. So we're going to set the top bit, which is the 0 address, to a 1. That's our input. So we have a 1 input and we're targeting bit number 1. So if we click synchronize, then we can see that it's set there. Now let's say that we want to set bit 2. So we change the address to the second bit. So value 0, 1 we could say, or just 1. So we have a 1 input for the second bit and then we synchronize. So I think this works. And then we can reset them, of course. If we turn off our data, then we can synchronize, turn it off. And then we can also clear the top bit by still having a 0 input, but now speaking to it essentially by addressing it at a 0. So this works out pretty well, very simple. I think too simple maybe. I should add more to this mini project. But I think this helps me to sort of visualize how we'll use this going forward. Right now it's a very simple switch. There's no actual decoding or logic necessary. But we can see that very easily if we had more addresses, we could just decode it, but the rest of the circuit would stay the same. We'll still have the input going to all data inputs for all of our bits. And then the addresser will just select which clock we're talking to at that moment. Right now we only have 2 options, so a manual switch works perfectly because it's either one or the other. The next time what we can do is issue each of these a 2-bit address, and then we'll actually have to use a decoder to access those clocks. We'll still have the execute button, which ultimately will come from the CPU's instruction. But for now, we'll just manually move it. So in this case, this is the most basic, I guess you could say, memory addresser that we have. So cool. All right, so let's see how that works next time.